Alright, so the video got cut off and I'm gonna just try to pick up where I left off, even though I'm not exactly sure where that was because I kept talking for a lot longer. The point is that I finished uh, writing all this stuff out, and where I left off was pretty much talking about the different colors of the hot wire, okay? So once again, trying to make it simple, trying to keep it short and keep it with the information that you really need to know. Um, just going back over some things. One circuit requires 3 wires, okay? Those 3 wires are going to be your ground wire, which is also known as your grounding wire. They call it the ground wire, which is the green wire, but it's also considered the grounding wire, okay? It's grounding the system. So the green is always going to be the ground. Ground, green. They both start with a G. And the ground wire is always going to be the grounding wire. I've seen that in some questions where they're like, what color is the grounding wire? They don't call it the ground wire. They call it, what color is the grounding wire? So keep that in mind and learn that. Okay? The second wire that it requires for that circuit is a neutral wire. The neutral wire is going to be white for low voltage. Okay, the neutral wire is the wire that's bringing the electrical current back to the panel from the light or from the receptacle, okay? And the neutral wire is always going to be white for low voltage, and it's also going to be called the grounded wire. I've seen that in some questions too. Usually they have all the 3 questions. What color is the grounding wire? What color is the grounded wire? And what color is the ungrounded wire, okay? They say that to trick you, but that's what I'm telling you, and you need to learn this. Once again, the ground wire is the green one, and it's the grounding wire. It's grounding the whole thing. The neutral wire, it's also considered the grounded wire because it's being protected from the green wire. They're connected inside of the panel. Without getting too complicated or into it, pretty much the grounded wire. This is the green wire is grounding the whole thing. It's grounding the hot wire and the neutral wire. Now I'm sorry. Let me rephrase that. The ground wire is grounding the whole system, but it's really just grounding the neutral wire. Okay? Now the neutral wire is the one that's actually being grounded by the grounding wire, okay? I hope you're following along. So learn that the neutral wire is also considered the grounded wire, and it's always going to be white for low voltage. All right. Now the third wire that it consists of is the hot wire. The hot wire is the wire that's actually bringing the electricity to the device, to the receptacle, and that wire is going to be one of 3 colors. Like I was saying in the last video, they make them different colors so it's easier to identify inside of the panel because there's a ton of wires inside of the panel. And even when you're opening up certain boxes, if you open it up, you're like, okay, that's blue. That's the circuit color that goes along with the circuit color that it should be that I'm looking for. If it's red, then okay, definitely not the one I'm trying to mess with, right? So with low voltage, the hot wire is going to be one of 3 colors. It's going to be black, red, or blue. And I'm gonna go into this a little bit more in detail here in a little bit after all of this, but make sure you remember it in that order. That's why I wrote this. So the way I remember it is BRB, like the acronym be right back, like when you're texting, BRB, be right back. I use this because it not only has it, black, red, blue, and it'll remind you that, the colors for low voltage is black, red, blue. It's not yellow because there's no yellow in BRB. But also it tells you in the order. Black, red, blue. Alright? Now, I'm talking about low voltage only, right? I'm saying the neutral wire is always going to be white for low voltage circuits, and the hot wire is going to be either black or red or blue for the low voltage circuits. What I mean by that is low voltage circuits simply means that anything from 24 volts to 207 volts, okay? Now, you're never going to see what voltage is considered 97 volts. No, the only three voltages you're gonna hear about is 24 volts, 120 volts, and 207 volts. You're not gonna hear 190 or anything in between, even though if you were, it would still be considered low voltage, because low voltage is anything from 24 volts all the way up to 207 volts. The most common thing you're gonna hear is 120. Okay, 24 volts is for data, guys. It's for communication. You know, your thermometer, your doorbell, things like that. We don't really mess with any of that stuff, so don't worry about that. But 24 volts is considered low voltage. All right, 207 is the highest low voltage out there, right? So that's, you know, it only goes up to 207. Anything above 207 is going to be considered high voltage. But the thing you're going to hear the most is 120. Like that light fixture is a 120 volt fixture, things like that. All right, so 120 is low voltage always here in China. 207, which is when you're talking about panels and things, which I've seen that in some questions. 207 is still considered low voltage. All right. And low voltage is really just like your average power source. It's gonna, you know, power up all your chargers, your you know, blow dryers, everything that you connect into a regular wall outlet. That's 120 volt. That's standard, right? Now there's some things. Obviously, there are things that need more power, like your dryer, your stove, your AC unit, and when, you know, since we're gonna be working commercial, you know, you're gonna see these humongous machines, like machines the size of a house and things like that. Obviously, those are not gonna be powered by 120 volt like a charger, like a phone charger is, right? So that's when high voltage comes in. High voltage is mainly found in commercial. It's also found in homes for your stove and your dryer, your AC unit, like I just said. And the only difference, everything about high voltage is the same concept. You need 3 wires for high voltage, with some exceptions, and I'll get into that a little bit later. But for a regular high voltage circuit, you need your hot wire, your grounded wire, which is your neutral wire. Remember, it's the same name, grounded and neutral wire, and your grounding wire, or your ground wire, which is the green one. The only thing that changes is the colors of your neutral and your hot wires. And the reason that it changes is to help the electrician. Please excuse my dog. The only reason it changes is because it's meant to help the electrician know or differentiate, this is high voltage, this is low voltage, okay? The reason that's important is because you want to take a lot more precaution with high voltage than with low voltage. You should always take the same amount of precaution, but when you're talking about high voltage, things change a little bit. You need to be 10 times more serious, 10 times more careful, things like that, okay? So once again, high voltage, the only difference is it has the same concept, everything. The only thing that changes is the coloring of the hot wire to help you identify that it's high voltage and not just low voltage, and the neutral wire, once again, to help you identify, hey, this is high voltage and it's not just low voltage, okay? Other than that, the biggest difference, like apart from the ways to identify the wire, is it's simply more power, okay? And high voltage is going to be 480 volts and higher. It can go up to 600 volts, 9, 12, 1100 volts. Anything above that is considered high voltage, okay? So if you ever see 480 volts, and you're going to see that a lot in commercial, that's high voltage, okay? 277 volts is also, 277. You're going to see a lot of 277 too, and that's mainly for like the lights in commercial buildings, things like that. So anything above 277 is going to be considered high voltage, okay? The most, like I said, for low voltage, you're going to hear 24 volt, 120 volt, and 207 volt. Mainly 120 volt for you as an electrician, right? That's what you're going to mainly hear. This is going to come in when you're talking about panels and things like that, electrical panels. For high voltage, the ones you're mainly going to be working with is 277 volt, and 480 volt comes in when you're like working with transformers, panels, things like that. You're not really going to be working a lot with 480 volt unless you're, with those things. So whenever you see 277, know that that's high voltage. So let's talk about this. The hot wire, once again, high voltage requires 3 wires. The hot wire is going to be either brown, orange, or yellow. And the acronym that I use to remember this is BOY, B-O-Y. Once again, the reason for that is because it tells you brown, orange, yellow, but not just that, but it tells you the order, because the order is super important as well. So BOY tells you, okay, there's a color with brown, with B, oh, that's brown. A color with O, that's orange. A color with Y, that's yellow. And it tells you, and you're like, what order was that in? I can't remember. Was it yellow, orange, brown, brown, yellow? No. Boy, if you remember boy, you're like brown, orange, yellow, in that order, just like BRB, black, red, blue. Okay? So that's what I used to remember. If that helps out, if you find it any other way, if you just learn it, good. Your grounded wire or your neutral wire, once again, we mainly call it neutral, but I'm saying grounded so you can get used to it, so you can really learn it. That's going to be gray. It's not going to be white. For a high voltage, it's going to be gray, okay? And then your green or ground or grounding wire is going to be either bare or copper. For high voltage, it's always going to be green, okay? It's very rare for it to be bare. For low voltage, same thing, but there's some instances where it is bare, like, some from devices or things like that. But yeah, so that's the main thing right there. The main thing here is you have to learn that a circuit consists of 3 wires, your hot wire or your ungrounded wire because it's not grounded, your second wire, which is your neutral wire, which is your grounded wire, and your third wire, which is your ground wire or your grounding wire, okay? Always, always, always remember that the ground or grounding wire is green or bare copper. Always remember that your neutral for low voltage is white, for high voltage it's gray, and your hot wires is going to be BRB, black, red, blue, in that order for low voltage, and boy, brown, orange, yellow for high voltage, in that order. Low voltage is 24 volt, 120 volt, 207 volt, 120 being the most common, but remember 207 because I've seen that in some questions. And high voltage is going to be 277 and 480 volts. Mainly going to be working with 277 volts, okay? Learn all of this stuff. If you have to, go back and, rewatch this video 10 times if you have to, but learn all of this stuff, okay? Alright, so here's the next thing that we're going to talk about. It's kind of there already, but my phone cut off again. It's okay. The next thing I want to teach you, because sometimes they do ask you this question, they're like, what color is circuit 53? What color is circuit 13? And then you have to tell them what color that is so they can know that you understand that concept, okay? They don't do this always, but they have done it in the past. And a lot of people don't know this. So if you show them that you know this, it'll be a great advantage to you, okay? So, pretty much what I said, this is your panel in your house, okay? This is your panel. These are the wires from the power lines coming into your house, into the panel. And then from there, it's feeding all these are all switches. These are all breakers, okay? Let me just explain it over again. And I'm sure you've seen this before. If not, you have at least one, probably 2 of these panels in your house. If you want to look at it on your own. But here's your panel, okay? And this has a section here in the middle, and it's broken into 2 sections. And then it's broken into small little rectangles like that. Okay? These are your breakers. This is your panel. These are your breakers. Just making sure it's still recording. These are your breakers, okay? These are your switches, so to say. The panel's being powered from the power lines, and then this is feeding your entire house. But let's say you go to a customer's house and you're working in their kitchen. you don't want to leave, you don't want to turn the power off to the entire house, because what if they're there? You know, they're doing things. So what you do, or the way this is set up, is that your entire house is powered by this, but it's broken into different sections. Not only because one breaker can only power a certain amount of things, or like a certain area, but also if you're working in the kitchen, you'll have a little diagram here in the door, in the other side of the door, and you just find kitchen is circuit number 15. Then you find circuit 15, turn it off. The rest of the house still has power, but the kitchen is completely off, so you can work on it safely. Okay. Now these are all breakers. They're called breakers. And like I said, this whole section is broken into two sections. You have a left side and a right side. This is going to be independent. The left side is going to be independent of the right side. Okay. The right side is always going to have even numbers, and the left side is always going to have odd numbers. Okay. Now, what circuit number is circuit 8? Can you answer that? Probably not right now, but you will by the end of this. Okay. So the way this is, structured is this. You pretty much go from 1 all the way to, it doesn't matter. Like some panels have only 20 spots, some have 70 spots. It depends on the size of the panel, if it's a house, a commercial, whatever. But it's always going to be like labeled like this. This is going to be circuit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc., etc. Okay? You see how you start off at the very top and then just go to the right? 1, 2, then go to the second one. 3, 4, 5, 6. That's the order that all of the panels are going to be like always, okay? Now here's what I just said. This left side, the way when you're working with numbers and the colors of the numbers, you work with only odd numbers or only even numbers, okay? So this left side, as you can tell, if you go down, once you actually start working with the panel, you're going to go down with it. So it's going to be 1, 3, 5, 7, 9, 11. You see how all those are odd numbers? That's because that's the left side. The right side is all even numbers, 2, 4, 6, 8, 10, 12, whatever. So the reason I'm saying that is because let's talk about low voltage, okay? Low voltage, we said the colors for low voltage, the hot wires. These are all going to be hot wires because this is the electricity right here, okay? Circuit 1 is, the hot wire is going to come out of here and go to wherever. So low voltage we said is BRB, right? Be right back, black, red, blue, and I said that it's in that specific order, remember? This is why. This is black, red, and this is blue. In that order, okay? So when you're looking and seeing, okay, the color for circuit number 5 is what? You gotta first see, okay, you're trying to figure out what color 5 is. 5 is not an even number, so even numbers are gonna all of a sudden disappear. If you're trying to figure out what color circuit 5 is, that means you're gonna look on the left side and left side only. So you're not gonna go, let's see, 1, 2, 3, 4, 5. Black, red, blue, black, red, blue, black, red, blue. No, you're gonna go 1, 3, 5. That's gonna be the order of it. If you're trying to figure out circuit 5, you're gonna go, okay, so we got circuit 1, circuit 3, circuit 5. And if you wanted to figure out circuit 11, you'd be 7, 9, 11, okay? This is the order. And this is where this comes in. Circuit 1 is gonna be black. Circuit 3, which is technically the second circuit of the left side, but because the entire panel is structured 1, 2, 3, 4, 5, like, from left to right, that's the way the panel is structured, okay? But when you're talking about wires, you're going to be looking at the left side only. So it's going to be circuit 1 is black, circuit 3 is red, circuit 5 is blue. And that's just, you see how that's black, red, blue, BRB, black, red, blue? That's the order I was talking about. After you get to blue, it's going to repeat itself always. No, unlimited amount of times. Black, red, blue, black, red, blue, black, red, blue, until you get to the end of the panel and there's no more, okay? So if you wanted to figure out circuit 5, you wouldn't be like, okay, If it's black, red, blue, you want to go 1, 2, 3, 4, 5. Okay, black, red, blue, black, red. Oh, circuit 5 is red because that's wrong. Like I said, if you're working with odd numbers, only consider odd numbers. So it'd be 1, 3, 5, 7, 9. You want to figure out fives. 1, 3, 5. So it'd be black, red, blue. And 5 is blue. If you wanted to figure out circuit 9, 1, 3, 5, 7, 9. That means black, red, blue. Repeats itself again. Black, red. So circuit 9 is red. And that's true. So that's how you do it. If you were trying to figure out what circuit is number 10, that means you're working, 10 is an even number. That means you're working on the right side. You completely forget about the odd numbers. And you're like, okay, it's not 1, 2, 3, 4, 5 because you're forgetting about the odd numbers. So it'd be 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. That means, once again, the same thing. Start with black, red, blue, and then repeat it. Black, red. 10 is red. So then if you do it here the long way, okay, circuit 2 is the very first circuit at the top, but we're doing the even numbers only, the right side only. So then you start from the very beginning. That's black, circuit 4 is red, circuit 6 is blue, and then repeats itself. Circuit 8 is black, circuit 10 is red, circuit 12 is blue. Okay? Now there's a fast way to figure out what color each number is. I just wanted you to get the concept of it, okay? So odd numbers are always together. Even numbers are always together. And for low voltage, the hot wire, remember I said it's going to be either black or red or blue? This is what I was referring to. It depends what circuit number it is. And the circuit number is going to be, the blueprints are going to tell you, okay, if I'm trying to work on this area, then it's going to be circuit 5. It's not something that you already know. Okay, this should be circuit 5. No, they're always going to tell you what circuit it is. They're always going to tell you that. So you don't need to worry about what circuit is it. You need to figure out what color is that circuit. Okay? For low voltage, it's BRB. And for high voltage, it'd be this exact same thing, except instead of it being BRB, it's going to be boy. Remember? Boy, brown, orange, yellow. So then it'd be circuit 1 would be brown, circuit 3 would be orange, circuit 5 would be yellow because it's in that order, and then it would repeat itself. Circuit 7 would be brown, orange, yellow, etc., until it gets to the end. If you're trying to figure out what circuit is 12 on a high voltage, and that's what they ask you, and that's what you got to be careful with, because if they ask you, they'll ask you that. What circuit color is 10 on a high voltage circuit? Or what color is circuit 10 on a 480 volt circuit? That's when you have to put things together. 480 is high voltage. Circuit 10 would be, let's see, 2, 4, 6, 8, 10. So once again, do the order. Start with boy, brown, orange, yellow, brown, orange. 10 would be orange. Brown, orange, yellow, brown, orange. Yeah, I was getting a little confused because that's low voltage colors. So if it's high voltage, do this same thing, but with brown, orange, yellow. If it's low voltage, do it with black, red, blue, okay? And that's that. Now, that's your hot wire only. We were only talking about your hot wire. Of course, in that same circuit, you're going to have a green wire, which is your grounding wire. And you're going to have your neutral. For low voltage, is going to be white. For high voltage, is going to be gray. Okay? Now that you know that, I'm going to teach you the shortcut. Okay? If they're like, what color is circuit 12? This is the formula. I keep checking to see if this is still recording, okay? This is the formula. X is the circuit number. Remember, they're going to tell you this. You don't know. You're not going to be like, okay, I have to know what circuit number it is. No, they're always going to tell you what the circuit number is. So that, don't worry about that. Okay, X is going to represent the circuit number. This is the formula to figure out the colors. You do X divided by 6, and then you're going to get your answer. Your answer is going to be Y, okay? Y, but you're going to have some things left over with a remainder of whatever. I'm trying to make this not complicated. Let's say, what color is circuit 12 on a 120 volt circuit? Okay, so first of all, you got to figure out 120 volt is low voltage. So I'm going to use black, red, blue, BRB. 120 volt is low voltage. That's BRB, black, red, blue. Now, you know what colors are going to be possible, right? Now you go, okay, they just gave me the circuit number. They wanted me to figure out what color is circuit 12. They told me 12. Like I said, they give it to you. So we'll put here 12 for X. 12 divided by 6. 6 is a number you're going to always use. That's a standard number. No matter what circuit number they tell you, you're always going to divide it by 6. It doesn't say what circuit number is 1. It doesn't matter if they say what circuit number is 50 or what circuit number is 357. You're always going to get that number and divide it by 6. Okay, so remember, divide by 6. 12 divided by 6 is 2, right? But you have no leftover numbers. If the answer gives you a full number like this, it's 12 divided by 6 is 2. That means 6 fits perfectly into 12 2 times, right? If it gives you a whole number like this, it's always going to be the last color, okay? If you're talking about low voltage, which 120 volt is low voltage, it's going to be black, red, blue, right? Those are your 3 possible answers. So you get 12, you divide it by 6 always, and you get a whole number. If you get a whole number, it's always going to be your last number. In the low voltage, in this instance, it's going to be blue. If you were talking about high voltage, it's going to be, the possible colors is going to be brown, orange, yellow. And if you want to figure out what color is circuit 12 on a high voltage circuit, well, you do 12 divided by 6, it gives you a full number. So that means it's going to be the last color, yellow. No matter if it's 30, they say what circuit color is 30? 30 divided by 6 gives you 5. Perfect number, perfect whole number, because 5 goes into 6. 5 goes into 30. 6 goes into 30 5 times evenly, right? That means it's going to be the last color of your, whether it's low voltage or high voltage, blue or yellow. Now, let's say it doesn't give you a full number. Let's say what circuit number is 20. They ask you what circuit number is 20 on a 277 system. You say, okay, 277 is high voltage, okay? So then my possible answers are going to be high voltage colors, which is brown, orange, yellow. Excuse me. Okay, so brown, orange, yellow. You do the same thing. 20 divided by 6, because you divide by 6 always. That's going to give you, how many times does 6 go into 20 evenly? It goes 6, 12, 18. 3 times evenly. And that gives you 18, but you have 2 left over, okay? So 6 goes into 20 3 times evenly, but you have a remainder of 2, because that would only give you 18. You're trying to figure out for 20, so that'd be remainder of 2. In this instance, here's the trick, because they're not all going to give you whole numbers like this. The trick is to look at your answer. Okay, it goes evenly 3 times, but I have 2 left over. You're going to forget about the 3 because that's a full number. Forget about 3 and look at how much is your remaining number. Right here you have 2 left over. So then you're going to pretty much go back and pretty much put it into this. Go 2, 4, 6. Even numbers are always going to start with 2 because that's the first even number. Odd numbers are always going to start with 1. So if you have a remainder of 2, you're only going to be looking at this number 2. 2 is the very top. On a high voltage, it would be brown. So then circuit 20 is brown, color brown. Okay. Now let me do another one just to make it clear. Let's say they ask you what circuit color is 35, okay? And instead of sitting there being like, well, 35 is an odd number, so 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, whatever, up until, okay, 35. And now let me go back and let's do low voltage this time. So it's black, red, blue, until you get to the same finger that said 35. Instead of doing all of that, this is a quick way. You go 35 divided by 6 always. How many times does 6 go into 35? You go 6, 12, 18, 24, 30. You can't go 36 because then, you don't have enough of that. So 6 goes into 35 5 times evenly, but you still have 5 left over because 5 times. All right, so I'm going to assume we left off at 35, talking about 35, okay? So if you want to figure out circuit 35, you do the same thing. You divide it by 6, okay? How many times does 6 go into 35? Let's see, 6, 12, 18, 24, 30, 36. You can't go 36. That means 6 goes into 35 5 times evenly. So go 5 with a remainder of 5, because if 6 goes into 35 5 times evenly, that'll be 30. So you have 5 left over, right? So the remainder is 5. So in this case, you forget about the whole number and you just look at the remaining number, okay? The remaining number is 5, and then you go back. 5 is an odd number, so then you just go down 1, 3, 5. And then if it's low voltage, black, red, blue, or if it's high voltage, brown, orange, yellow. Okay? 5 would be blue or yellow. Okay? Now, it doesn't matter that if it's a whole number, it'll give you yellow or blue. And if it's a full number with a remainder of 5, it's going to give you yellow or blue. It doesn't matter, okay? They're both right. Right, so then pretty much what's going to happen here is you're going to notice that whatever number they tell you, like figure out circuit number 50,000. You're going to divide it by 6 always. The 6 go evenly into 50,000. If it does and it gives you a full number, a whole number, automatically the last color. In low voltage, it'd be black, red, blue. Blue is the last color, so it'd be automatically blue. High voltage would be brown, orange, yellow. Yellow is the last one, automatically yellow. Okay? If 6 goes into the number evenly and there's no remainders, it's always going to be the last color, automatically. If it does not go evenly into that number, it's always going to give you a remainder of 1 through 5. It's not going to give you a remainder of 6 because that means it would fit evenly into the number. And it's never going to give you a remainder of 7 or more. It's always going to give you a remainder of 1 through 5, or it's going to fit evenly. If it doesn't fit evenly, and it gives you a remainder between 1 through 5, then all you have to do is, do the little, just count it out. If it's odd numbers, you go 1, 3, 5. Let's say it gives you a remainder, it had a remainder of 5, that's black, red, blue. So that'd be blue or yellow in high voltage. If it gives you a remainder of 3, that's odd number. So you go 1, 3, 5. Black, red, blue. Red is 3. There. If it gives you a remainder of 2, you go even numbers. 2, 4, 6. 2 would be black or 2 would be brown. 3 and would be orange or red, like we just said. And that's it, guys. That's pretty much it. That's how you figure out what color a circuit number is really quick. A lot of people don't know this. A lot of people just pull out a cheat sheet. And if they ask you this, great. You'll be able to figure out what color any circuit number is. I've seen that on tests. If they don't ask you, then always mention it, because that'll set you apart, and that's always a good thing to know. And that always, that's always a bonus. So that's all for the wiring concept. That's all you need to know for the wiring. Yeah. That's all you need to know for the wiring. just the colors, how many, all the different colors in a circuit, the different colors of low voltage or high voltage, the different names for the wires, the way it's set up in a panel, the way you look or the way you go up to a certain number to figure out the color, and the way you figure out the color. Okay, look over these videos, learn all this stuff. The next video, I'm actually going to start teaching you about another concept. Okay, so we're done with the wiring, and yeah, that's it. I'll see you guys in the next video.